Year 10. This is lesson 2 now on solving linear simultaneous equations. What I would recommend is making sure that you pause the video after I've been through each example and make some key notes so that you can follow it as you go in through. If we have a look at this example here, okay, again, we've got two equations, 3x add y equals 7, and we've got 2x plus 3y equals 7 as well. So what we're going to need to do, as we did last time, is we're going to need to make sure that we label each of our equations number 1 and number 2. So we've done step number 1 this time. If we have a look carefully at the two equations, we can see that the top equation has just the 1y. We can see equation number 2 has got 3y. In this case, they're not the same numbers in front of the y, so we're going to have to do a little bit more work with these before we can eliminate one of the variables. So what we would look at is in equation number 1, how can I make the y 3y? Well, I can make sure I times y by 3, and that will make 3y. In this case, though, I must make sure that I don't just multiply the y by 3. I need to multiply through the whole of this equation by 3. I'll rewrite that. So I will do 3 times 3x, which gives me 9x, 3 times y, which gives me 3y, and 3 times 7, which gives me 21. I don't need to change this second equation here because it has already got in the equation 3y. So I just write it down the equation again. Because I've changed one of the equations I've started with, I'm now going to label it differently. I'm going to call it equation number 3. And although I didn't change equation number 2, I'm going to call this one equation number 4. You can now see that within the question here that I've got plus 3y on both equations. That now allows me to do the following. I can eliminate the y's in this case. Have a look. Do they have the same sign? Yeah, they do. They both have positives in front of the 3y. Therefore, the rule is same sign, subtract. So we're going to do some subtracting. This time, if I subtract going down the column, then 9x take away 2x is going to work. It's going to give me 7x, and 3y take away 3y is nothing. And 21 take away 7 here gives me 14. I can now see that I can solve this equation. 7x equals 14. So how many 7s are in 14? It's 2. So x equals 2. Okay, what I would like to do now is I would like to try and find what y is in this equation. That means I need to substitute back in the value for x equals 2. And I need to do that by looking at one of the first two equations. So if I pick equation 1, and I am going to substitute, I'm going to write sub in short for substitute, x equals 2, and I'm going to substitute it into equation number 1, then it's going to give me the following equation, okay? It's going to give me 3x plus y equals 7. Now I know x is equal to 2, so I would work out 3 times 2, which is 6. So I get 6 add y equals 7. Now 6 add what makes 7? Well, 6 add 1 makes 7. So y equals 1 in this case. So my two solutions for the question here are x equals 2 and y equals 1. Now pause the video and make some key notes on that example, please. Right, we're going to have a look now at a second example here. Okay, so we can see our two equations here are 4x plus 2y equals 18 and 3x take away y equals 11. Again, if we look carefully at the coefficient of y, one of them has got a 2 in front, and one of them has got nothing in front of it, which would make it 1y. So they're different at the moment, so they can't be eliminated. If I look carefully, once I've labeled my equations 1 and 2, I can make equation 2 up to 2y by multiplying it by 2. Again, I need to multiply through the whole of this equation here by 2. So As I'm not changing equation 1, I can write down that 4x plus 2y equals 18. And if I multiply equation 2 through by 2, then I get 6x. Take away 2y equals 22. I now label these equations 3 and 4 because I have to change one of the equations. Now you can see in here that I've now got 2y in both cases. So I have a look. Do they have the same signs in front of them? Well, the answer to that is no, because one has a positive sign and one has a negative sign. So this time I'm not going to subtract to eliminate y. I'm going to add them together. So it means now I'm going to add together going down the columns. So in this part here, I've got 4x plus 6x, which makes 10x. 2y add minus 2y makes 0y, so that's nothing. And 18 add 22 here makes 40. So now I'm left with the equation 10x equals 40. How many 10s are in 40? It's 4. So x in this case is equal to 4. So I've now found my x value. I now need to do what I've been doing previously, and that's to do step 3 here, which is to substitute back in that value to find the value of y. I'm going to choose to do that with equation number 1. So again, I'm just going to put sub in for short for substitute. X equals 4 into number 1. Now number 1 looks like this. 4x add 2y equals 18. Okay, so I'll do this bit by here. 4x add 2y equals 18. Now I know that x is equal to 4. So 4 times 4 makes 16. Add 2y equals 18. It's a two-step equation. So if you remember, now we take away 16 from both sides of the equation. So I take that 16 from there, and I take 16 from 18, which leaves me with 2. So I know that 2y is equal to 2. And if I find out how many 2's are in 2 is 1, then y equals 1. And again, now I've solved my simultaneous equations. X equals 4 and y equals 1. Okay, pause the video again now and have a go and write down some keynotes and then have a go at the following main task. Pause the video and have a go. Right, here are the solutions to those questions. So check over your work, mark and correct it. If you have any questions, please let me know on your return next week. Okay, here's a checking question then. All right, pause the video and have a go. Welcome back. Okay, let's go through the checking question then. So we've got two equations again, equation 1 and equation 2. Okay, so as you can see again, the coefficient in front of y is 2 and 1. So by quickly multiplying equation 2 through, we can change that. So the first equation remains as 3x plus 2y equals 11. And multiplying through the second equation by 2 will get us 2x. Take away 2y equals 14. Call them number 3 and number 4 because we had to change one of them. Again, the rule, if you can remember, have a look at the signs in front of 2y. They're different. So in this case, we're going to add together the two equations. So add together 3x, add 2x to get 5x. 2y, add minus 2y again will be 0y. 11 add 14 will get us 25. Okay. Now solve this one-step equation. How many 5's are in 25? It's 5. So x equals 5. We can now use x equals 5 to substitute back into one of our two equations. Okay, so I'm going to pick equation number 1. So I'm going to write that I'm going to substitute x equals 5 into equation number 1. Equation number 1 is this, 3x plus 2y equals 11. Now x equals 5, so 3 times 5 here makes 15. So I've now got 15 add 2y equals 11. Now I've got a two-step equation to solve. So if you remember back to those rules, take 15 away from here, take 15 off 11. Think carefully about that. Taking 15 away from 11 takes us into a negative number. It will be negative 4. 2y will be equal to negative 4. So what is negative 4 divided by 2? It is negative 2. So to solve the equations, we found that x equals 5 and y equals -2. Thanks for listening. I'll see you again next lesson.